Hello, good day. My name is Angel Barracin. I'm a student of Mechanical Engineer. This is a video especially for the signature Mecanica los Fluidos. This is for the University Fundación Lutero Libertadores. In this video, we're going to talk about some theorems, about Bernoulli's theorem and Torricelli's theorems. Also, since my uh, final project for this signature is about Reynolds numbers, so we're going to talk about also discuss a little bit of that. So, well, what we have here is the following. We have Bernoulli's theorems. Principles, applications of Bernoulli's theorems in mechanical engineering. The principle, Bernoulli's theorems decrease the relationship between fluids and pressure, velocity and elevation, straight as velocity increase, pressure decrease. We have here an example that we can analyze how maybe the pressures and the fluids, in this case, maybe for example, the air placed in a plane. And I mean, in order the plane can fly, this is a lot of Bernoulli's theorem, works a lot of that. Of course, different kind of or kind of the physics, but Bernoulli's is there. Applications, well, in the example we have here. So we have here the Bernoulli equation. So Bernoulli equation say that is P of pressure but plus a half of the density times velocity square plus density of the fluid times gravity times the height of the situation. Here we have all the kind of part that is Torres theorem. We have the fluid flow and discharge calculation. Torres Prince talks about this theorem describes the relationship between the velocity of fluid existing in an orifice and the height of the fluid about the orifice. For applications, and this theorem we have that is to calculate fluid discharge rates and optimize the design of tanks, valves, and other hydraulic systems. For the formula of the Torricelli equation, we have that B is equal to rho square and 2 times gravity times height. So that relates the fluid's velocity to the height of the fluid about the orifice. So this is the Torricelli theorem. Here we have to talk about more specific because it's the topic that we have in our project is Reynolds numbers, influences of fluids, mechanics, and design. We have the definition. Random numbers is a dimensionless quantity that represents the ratio of inertia to viscosity flows in a fluid flow. Significance, random numbers is crucial to determine the flow recurrent, laminar or turbulent, and predict fluid behavior in mechanical systems. And what do you wonder, like, what is laminar, what is turbulent? Laminar is what we have, like, the fluid is kind of calm down, is continuous, is just flowing as normal. All the molecules is going just straight, no change. Is the more harmonious status that we have the fluid. Turbulence we have here when all the particles are like crashing ones with another, one for this or for that part, or behind if trying. So it is a completely crazy in that part. So this is the turbulent. Also, we have, I mean, turbulent is the more useful for some situations, maybe talking about turbines, pumps, and different more hydraulic systems. Something that have more like with power is more like turbulent. Something that is not related with that, laminar. It depends about the system that we're working about. Well, we have here the calculations or the formula about this theorem. So, well, we have that the number of the Reynolds number is equal to density times velocity times, and well, here in the presentation we represent with the letter L. That means the diameter of the system. I mean, the diameter that is that for the fluid is flowing. So that all of this divided for mu. This mu is about the viscosity, the dynamic viscosity of the fluid. So when we have for talking about this, we have to take in account the viscosity, the dynamic viscosity. If we have different fluids, we have to analyze all of them in order to get all the information as possible. Also, we have to have like the causal uh, equations, formulas, and also the continuity formula equation. So this is a lot of that we have here. Well, we have here like a review of the formulas of Bernoulli's, Thomson and Reynolds number equations. And well, just to remember the principal application for these formulas are using the design of aircraft wings, fluid mirrors, error system, and another mechanical engineering application. We're studying this like in fluid mechanics. So this is for what we're seeing all of this information. Well, I consider that this has to be enough information about for this session. So I appreciate your patience if you arrive here to the end of this video. Well, I really hope that we can see next time, maybe in another next signature. So like I mentioned, this is the final value for this signature, but of course we can continue seeing different kind of videos in another signatures next semester until we hit this career. Okay, so thank you for watching my video. Well, I really hope you have a good rest of the day.